This section is going to look a lot like 6.2. Now we're going to be proving that the quadrilaterals are parallelograms. So now we're just flip-flopping or taking the converse of each of the theorems. So now instead of saying, hey, this is a parallelogram, what's that mean? The opposite sides are congruent. Now we're going to say, if the opposite sides are congruent, then it's a parallelogram. So we're just taking the converse, which means we're flipping the hypothesis and the conclusion. So our first theorem is 6.6, and it is if both pairs of opposite sides are congruent, then it's a parallelogram. Okay, so we're talking quadrilaterals. So if we have a quadrilateral, which is a four-sided figure, so if this four-sided figure has the opposite sides are congruent, then we can say it's a parallelogram. Remember, the parallel symbol with gram is parallelogram. That's how I shorthand it. Okay, next one, theorem 6.7. If both pairs of opposite angles in a quadrilateral are congruent, then it's a parallelogram. Okay, what's that mean? That means if I have a quadrilateral, four-sided figure, and both pairs of opposite angles are congruent, then it's a parallelogram. Okay, theorem 6.8. If an angle in a quadrilateral is supplementary, what's supplementary mean? Adds to 180 to both consecutive angles, then it's a parallelogram. Okay, so if I have that quadrilateral four-sided figure, these are my opposite angles, they're both x. That means that this guy up here would have to be 180 minus x. It'd have to be supplementary to the other two angles. Theorem 6.9. If the diagonals of a quad bisect each other, then it's a parallelogram. Now, what does bisect mean? Bisect means it cuts it in half. So if I have my quadrilateral over here and my diagonals are drawn in, if those diagonals bisect each other or cut each other in half, then we know it's a parallelogram. And the last theorem for this section is theorem 6.10, which says if one pair of opposite sides are parallel and congruent, then it's a parallelogram. So that means if I have this quadrilateral, if these two sides, the up and down ones, are congruent and parallel, I can go ahead and say, yep, that's a parallelogram. Okay, so now for the practice, we're going to be using this stuff. So for the first part, I want you to tell me, are the following parallelograms? If so, explain why. So your explanation can just be one of the theorems that are above. Okay? The first one we're going to do is going to look like this. Okay, so for this one, I have a four-sided figure, so I have my quadrilateral. I also have my diagonals drawn in. With those diagonals, it shows me that they're cutting each other in half. They're bisecting each other. So come up here. Which one talks about diagonals bisecting each other? That would be theorem 6.9. So yes, this is a parallelogram. Why? Because of theorem 6.9. Try this one. Okay, so this one I'm given angles. Now, what am I given? I have my opposite angles on one diagonal, 60 and 60, but I don't have 120 and 120. So I'm not looking for opposite angles or congruent, but I do know these are consecutive, right? And these are consecutive. So they should be what? Supplementary. Supplementary means they add to 180. Well, 180 minus 60 is 120. So these should also add to 180. 180 minus 60 is also 120. So yes, now which theorem is that? That would be 6.8. What about this one? All right, so this one, I see one of my diagonals has a congruent sign. I see one pair of opposite sides are equal. But if I come up here to my theorems, I have to have both sides are equal or both diagonals bisect each other. And even if I look at 6.10, those opposite sides have to be congruent and parallel. We don't know that about number 3. So can I say that this is a parallelogram? No. Okay, you try this one. So here's your quadrilateral, and here's the information I'm giving you. Go ahead and pause. Tell me if that's a quadrilateral. If it is, why? All right, the next part that we're going to do is we're going to solve for the variable. Solve for the variable so that the quadrilateral is a parallelogram. So the directions are just going to be flip-flop from the last sections. Instead of saying this is a parallelogram, solve for x, now we're saying solve for x to make this a parallelogram. Very similar process. First one that we're doing, it'll look like this. What number is this? 4? All right, so for this one, if this is a parallelogram, what should we know about these angles? They're next to each other. They're not opposite from each other, which means they add to 180. So I have x plus 2x equals 180, which means 3x equals 180. Combine those like terms. Divide each side by 3, and x is 60. Next one I'm going to make a little bit bigger. Just make sure we can see it. Okay, so this one we have 3y plus 4, 2y plus 22, 2x, and 12. So now we're looking at diagonals. What do we know about the diagonals if this is going to be a parallelogram? We know that the diagonals bisect each other, which means this one should be equal to this one. So we have 2x equals 12. So x is 6. And then we should go the other way, which means this diagonal is also cut in half. So we have 3y plus 4 equals 2y plus 22. I'm going to get my y's on one side, so I'm subtracting 2y. And then I'm going to subtract 4, so y comes out to be 18. So use the theorems that we've taught you to find what's missing, okay? You're going to try this one. go ahead and pause, complete this one, and then you can move on to the homework.